Okay, let's start chapter 13, section 2. We're going to be factoring trinomials. And the trinomials are going to be of this form, x squared plus bx plus c. So more specifically, they will be degree 2 trinomials. And when we say of this form, the point is that the leading term coefficient is 1. These are also called monic trinomials, or more general, monic polynomials. I don't think the book uses that term. So what we want to do is we want to factor these into the form x plus r times x plus s. So that's our goal. So actually, let's take a look at this. So this is what I have. In general, x squared plus bx plus c, where b and c are integers. That's positive or negative whole numbers. And I want it to be equal to x plus r times x plus, I'm going to use m because that s looks a little bit too much like a 5. X plus m, where r and m are also integers. So this is what I have. This is what I want. So let's multiply this out. Let's just look at the right-hand side here. That's x squared plus rx plus mx plus rm. So simplified, that's x squared plus r plus m x plus r times m. And I want that to be x squared plus bx plus c. So we have the two conditions. R plus m has to be equal to b, and r times m has to be equal to c. So this little part right here is the work we have to find. This is our goal. And what I'm going to do is I'm just going to give you a formula or a method of doing this where all of the criteria is kind of built into the method, and it works for every type of polynomial. So let me just classify polynomials two more ways. So x squared plus bx plus c is a monic. Remember, monic just means that the leading coefficient is 1. Degree 2 trinomial. If, on the other hand, we have a leading coefficient that is not 1, so a is not equal to 1, then we have just a degree 2 trinomial. And we want to factor both of them. And these are always the easiest to factor. And to factor is to break it down, a sum. This is a sum of 3 terms right here. and we want to change it into a product. But the point is, this doesn't always work. Indeed, we have the last definition I'm going to give you is the following. Let me get my pen back. I guess I can just go there for my pen. Maybe not. Polynomials any polynomial, and in particular trinomials, which can't be factored, are called prime. So I'm going to give you an example, not of a trinomial, but of a degree 2 binomial that can't be factored. X minus 1. That can't be factored. The GCF between those two terms is 1, so this would be considered prime. Now we will find we're actually going to look at a specific example here in just a second, and I'm going to go through the entire method. All of this is just setting up the necessary concepts that you need. As it turns out, these are the easiest, and we're going to start with these. We're going to start with these, the type where the leading coefficient is 1. But our method will also work for these. And our method is good enough that it can always detect primes from those which are factored. So if there is a factorization, then we'll find it. And clearly, if there isn't one, we'll be able to tell that too. But here is the caveat. Here is what I want you to know. On exams, not necessarily homework, all trinomials can be factored. That means I'm not going to put any primes on the exam or quiz. And the reason being is students just give up. They don't find finding the factorization is a trial and error method. And students give up really fast and they say, oh, well, it's prime. And they just give up and put down prime. But know in advance on your quizzes, I'm going to carefully choose everything such that all of them can be factored. So let's actually start with the method. And on our home page, I think I have it up. Go to the modules view. Maybe that's a little bit too big. Close that window. Oh, this is the wrong class. Give me just a second. Let me get to your class. If you come down here, where did it go? Oh, maybe I was in the right class. I'm just in the wrong week. Here we go. This review video, Factorization of Trinomials, is just yet another review with more examples. So just letting you know that's there if you want to see a few more examples worked out. So we're going to factor. So we want to factor x squared plus 11x plus 30. Now, some of you learned how to factor in school and you feel comfortable with your factorization methods, the method I'm going to teach you is probably different than what you used. And if you feel comfortable with how you've learned to do it, then stay with it. But I'm thinking most of you have absolutely no idea how to do it. And I've taught this several different ways, and it seems like students retain this method better. So the first thing I always have to mention is we want to see what the GCF of all of our terms are. And usually the GCF is going to be equal to 1, in which case that leads to a trivial factorization. I can put parentheses around it and multiply it by 1. I didn't learn anything. But sometimes it's not. So if the GCF is not equal to 1, then you first factor out the GCF. And I think we might actually be doing some of that in today's lecture. So with that said, let's just start the method. So here's my polynomial I want to be factored. X squared plus 11x plus 30. So our method is going to be to draw, it's kind of like a tic-tac-toe board, but it's got a little bit of extra space here. There's a little bit lip right there, but this is just 4 squares like that. That's how we start, just like that. And what I do is I take each term of my trinomial and I write it vertically here, but I don't write them in this order. I write the x squared term first, the constant term second, and the middle term last. Factorization, the work always comes with the middle term. And what we're going to be doing is we're going to be entering in variable terms or whole numbers in each of these boxes and multiplying across and then multiplying down. But on the bottom, we're going to be adding. So let's start with the x squared term. I have to put a variable term here in this first box and a variable term here in the second box, such that this times this gives me x squared. And since they have to be variable terms, I have no choice. An x and an x goes in there. I'm going to do this a different color. So I have to have an x in here and an x in here. So when I multiply across, x times x gives me x squared. Now comes the guessing part. So in the guessing part, what I have to do is look at my constant term. And you want to break 30 down, and so it's the product of two numbers. So 30 is equal to 2 times 15, or 30 is equal to 3 times 10, or 30 is equal to 6 times 5. But it's also going to be important that that's not all of them. Of course, 30 is equal to 30 times 1. But we actually have to consider all factors. 30 is also equal to minus 2 times minus 15. 30 is also equal to minus 3 times minus 10. 30 is also equal to minus 6 times minus 5. 30 is also equal to minus 30 times minus 1. So this is the guessing step. So I'm just going to choose one of these factorizations. And I'm going to choose 3 and 10. Now 3 times 10 is equal to 30. So my row multiplication is satisfied. So now we start multiplying in the columns. 3 times x is 3x, and 10 times x is 10x. And I add these terms. But look, I need the result to be 11x. And my 3x plus 10x is 13x. So that's not going to work. I've got to change something. Now I'm not going to change what's in the top row. When our polynomials are monic, meaning the leading coefficient is 1, the top row always has to be x times x, period. So my only option to change is going to be what factorization I use for 30. And that's where the work is almost always going to take place here. It will always take place here in this row when our polynomial is monic, meaning leading coefficient of 1. So let's try 2 and 15. This is just getting a feel for things, okay? You might already know what the answer is. Well, 2 times 15 is going to give me 30, but 2 times x is 2x, and 15 times x is 15x, and when I add those, I'm getting 17x, and I need it to be 11x. Let's do one more thing. Let's try a negative factor in here. So this is just experimenting around. Some of you already know what the answer is. Let's try minus 2 times minus 15. Minus 2 minus 15. Well, minus 2 times minus 15 is 30, but x times minus 2 is minus 2x, and x times minus 15 is minus 15x. So now I'm getting minus 17. So the negatives certainly are not going to be helpful now. So let's go back and let's try. We still have 2 more, but let's try 6 times 5. So 6 times 5. Well, 6 times 5 is 30. X times 6 is 6x. And x times 5 is plus 5. So 6x plus 5x is 11x. So here is the thing. We have our table, but we don't yet have the factorization. The reason I'm doing this is because I had a student in this very class this semester at night who would get the table right. And you know, all of the work literally comes in the table, but then get the factorization wrong. So how do I get the factorization from my table? We go kitty corner. I just draw a little bit of ellipse going from corner to corner. And our factorization is always 2 things multiplied by each something in parentheses times something in parentheses. So the first is x, and down here, kitty corner, is a plus 5. So that 5 is positive. In here, you always put the x first, and going kitty corner down, it encapsulates 6. So we just discovered that x squared plus 11x plus 30 is equal to x plus 5 times x plus 6. So this is its factorization. Let's check to make sure that really is correct. The cool thing about factorization is you can always check to see if you have the right answer. So let's check. So we're going to multiply out x plus 5 times x plus 6. Well, that's equal to x times x plus 6. If you want to FOIL this, you can. Plus 5 times x plus 6. Well, that's x squared plus 6x. Here's our 6x. Plus 5x. Here's our 5x. Plus 30. And when I add those together, I get 11x, which is what I said it was. So this is the factorization. So now you kind of see the process. Let's just do some. This next one, so this is 1b. This is a polynomial in the variable y. It doesn't matter. Y squared plus 7y plus 10. So I come over here and I also like this too because you can do it in a small little bitty space. So I put my y squared my y squared term at the top, my constant term second, and my middle term at the last. So that's really the only thing that's kind of hard is remembering that the middle term is at the very, very last. And since this is monic, I only have one choice. It's automatic. 2 y's go here. So let's multiply things that will multiply toward to 10. Well, the first thing that comes to mind is 2 times 5. So let's go this way. Y times y is indeed y squared. 2 times 5 is indeed 10. So now let's do the multiplication down. 2 times y is 2y. 5 times y is 5y. And remember, this last row is addition. 2y plus 5y is 7y. So I've got my ingredients from my box. So let's find the factorization. So you just go kitty corner and kitty corner. So my factorization, and it doesn't matter which order you go in. You can start y plus 2 and then go y plus 5, or y plus 5, y plus 2. So this is y plus 5, y plus 2. So y squared plus 7y plus 10 can be factored into the product. Notice the factorization is the product of 2 degree 1 binomials. And that's always going to be the case. When we factor a degree 2 term into the product of 2 non-trivial factors, then we always, those factors, each one of those factors are 1 degree less than the original. So y plus 5, that's a degree 1 polynomial in the variable y. Y plus 2 is a degree 1 polynomial in the variable y. As a matter of fact, these are called linear factors. That's another name for degree 1 polynomials. So let's do the next one. So this is a polynomial in the variable x. It's a trinomial, a degree 2 trinomial. The GCF of all of the terms is equal to 1. So I have no choice but to try to factor it. So I just come over here and do my little box. This has got to be x squared. Constant term is negative. Take note of that. And then my last term is 3x. So this is, since this is a leading coefficient is 1, I have no choice but to put 2 x's there. And indeed, it fits. X times x is x squared. Now here I have to put a whole number times a whole number that gives me minus 4. That means exactly one of them has to be negative. But when I multiply down and add them up, I'm going to give a positive result. So of my two factors, the negative has to go on the smaller of the terms. So let's try 2 and minus 2. Well, then I'm going to get 2x minus 2x, and that gives me 0x. So that's not going to work. And I only have one other choice. My only other choice is 1 and 4, because those are the only way I can multiply two numbers to get 4, but this time I want it to be negative. So 1 and 4, and my observation said one of these have to be negative. Either I put the negative sign on minus 1, or I put the negative sign on 4. But since I'm adding these and the result is positive, I'm going to put the negative sign on the smaller of the two. So x times minus 1 is minus x. X times 4 is plus 4x. And minus x plus 4x is the same as 4x minus x, and it gives me 3x. So I have my table filled in, so the only thing left to do is extract the factorization. Right there it is. So my factorization is x plus 4. If it doesn't have a sign, it's considered to be plus, and x minus 1. So you can multiply that out, and you will discover that x squared plus 3x minus 4 is x plus 4, x minus 3. Boy, am I going insane, people? There we go. X minus 1. I wrote the wrong thing, I said the wrong thing, and everything about that was wrong. So x plus 4, x minus 1. X minus 1, x plus 4. Good. So let's do some others. So you should try to see about doing these yourself using the same method. So this is going to be 1D. X squared minus 4x minus 21. There are many, many techniques that you can use to factor polynomials. The reason I used to not use the technique I'm teaching you right now, and the reason I did is I've discovered experimentally that students remember it. They remember it after they leave, they come back and they remember it, or they can review it, and it's faster, and you don't have to try as many different options. So I'm going to say right now, here in just a second, we will not do 13.3. We will not cover. So the book, trying to please everyone, actually teaches you two different methods to factor. Neither one of them are the method I'm teaching you, but it's equivalent to this method. So we're just going to skip 13.3. So that's the reason you don't see anything. I'll just leave that there in case people are just fast forwarding. So here we go. It's got to be minus 4x, right? So because this is leading coefficient 1, those have to be x's. I mean, that makes the top row really easy when the leading coefficient is 1. Now let's think about this. I'm going to have to multiply together two numbers to get me minus 21. So that means exactly one of them is negative. And when I add them together, it's going to be a negative result. So of those two numbers, the larger of the two are going to be negative. So I'm going to try the obvious, minus 7 times 3. Minus 7 times 3, the larger of the two, I put the negative sign on. And minus 7 times 3 is minus 21. So now let's go the multiplication down. Minus 7x plus 3x. And minus 7x plus 3x is indeed minus 4x. So I have my factorization. Doing weird things today. There we go. So there's my factorization. My factorization, again, is always in parentheses. So it's x plus 3 and x minus 7. So x squared minus 4x minus 21 is equal to x plus 3 times x minus 7. So let's do E. Now, the method I'm teaching you is equivalent to so many other different methods that might actually be a little bit faster when we're given a polynomial like this. This method has two advantages. It's faster when we deal with polynomials, trinomials specifically, degree 2 trinomials, whose leading coefficient is not 1. And it's easier to look at all of the different possibilities. So here I have x squared, my constant term, and my middle term. So let's think about this. My constant term is positive, but when I add, these have to be x's. When I multiply down, they have to be negative. I have to have at least one negative, but so what this tells you is the factors you choose for 30 are both going to have to be negative. So let's try minus 3 and minus 10. So minus 3 times minus 10 is minus 30. X times minus 3 is minus 3x. X times minus 10 is minus 10x. Minus 3x minus 10x is minus 13x. So indeed, I found the right numbers. So it always pays to stop and reason. When your constant term and your middle term are of different signs, stop and think about what that is telling you. So this is equal to x minus 10 times x minus 3. And now let's try the last one, 1f. So we have x squared minus x plus 32. Yeah, pausing and trying to do these before I do them is probably a good idea. So these have to be x's. Since this is minus x, then when I look at my factors of 32, the larger of the two has to be minus. So 32 divided by 2, that gives me 16 divided by 2 gives me 8, divided by 2 gives me 4, divided by 2 gives me 2. So here's how this works. If I want to find out of all of these factors, I can go to the endpoints, and 32 is equal to 2, 1, 2, 3, 4, 2 to the fifth times 1, because I need two factors. So 32 is equal to 32 times 1. Here, I can do, it's equal to 2 to the 4th times 2. So I can only take 1, 2, 3, 4 of them, and then I multiply that. So 16 times 2, etc. So a lot of different factors. Divide it by 2, multiply it by 2. Divide by 2, multiply by 2. So I get a lot of different factors to give me 32. So let's go back over here and let's just think. So I'm going to have to multiply together two numbers, and the result is going to be positive. But when I add them together, the final result is going to be negative. So all of these factors, if I choose 32 times 1, I have to choose instead minus 32 times minus 1. So let's try minus 32 times minus 1. So that gives me 32, but then that gives me minus 32x minus x. And that's minus 33x, so that's not going to work. So let's try the next one. Minus 16 times minus 2. That gives me minus 16x minus 2x. And that's not minus x. That's minus 18x. So that's not going to work. So let's erase that one. Now let's try minus 8 and minus 4. Well, that's going to give me minus 8x minus 4x, and that's minus 12x. And now when I get down to minus 4 times 8, when I get down here, this is the same as this one. Since the signs are the same, it's going to be the same. So the end result is nothing works. So this polynomial, this degree 1 trinomial, is prime. And we were able to discover it by trial and error, noting that nothing works. So try this one on your own. So this is a polynomial in the variable m. It's not numbered. Once you practice this a lot, you can probably, when the polynomial is monic, meaning its leading coefficient is 1, you get kind of good at this. So here we have no choice but to put m's there. And here I'm going to put 1 and 16. That gives me m plus 16m. And that gives me 17m. So remember, don't forget to grab the correct factorization. The factorization comes from the kitty corner tic-tac-toe board section. Because it's really frustrating if you're able to fill out the entire table, but then you forget how to extract the factorization from this information. So if you got that, then you're doing really well. So let's go to the next page. So the first thing we're going to notice here is these are different types of polynomials. The leading term is not 1. And that's aggravating. Now, the method I'm going to teach you in the next lecture, we will actually be doing them with leading terms not equal to 1. But for this one, we're okay, because we're going to remember I'm going to remind you that we always have to factor out the GCF. Now when the leading coefficient is 1, there isn't anything you can factor out unless the constant term is 0. But here I'm posing the question, what is the GCF of 2x squared? Remember, you can just ignore the negative sign in 28. Well, since x does not occur in every term, we ignore that. But the GCF is then just the equivalent of the GCF of the constant terms, to 18 and 28. And we know the GCF is greater than or equal to 1 and less than or equal to the smallest of the terms. And it's always equal to the smallest of the terms if it evenly divides all of the others. And 2 evenly divides 18, and 2 evenly divides 28, so it's equal to 2. So we're going to factor out 2. So 2x squared divided by 2 leaves me an x squared. Minus 18x divided by 2 leaves me a 9 minus 9x. 28 divided by 2 is 14. So now if you'll observe, by factoring out the GCF, I now have a polynomial that I can deal with, because the polynomial in parentheses here has leading coefficient 1. So that's the polynomial we're going to try to factor. So x squared at the top, constant term next, and then middle term. So these always are x's. Remember, they're only x's because the coefficient here is 1. Now look, the middle term is negative and this is positive. That means the factors of 14 have to both be negative. So let's try minus 7 times minus 2. So x times x gives me x squared. Minus 7 times minus 2 gives me plus 14. X times minus 7 gives me minus 7x. And x times minus 2 gives me minus 2x. Minus 7x minus 2x gives me minus 9x. So I'm ready to extract my factorization. And you don't, if you're good at this, you certainly don't have to do this. But I'm going to, since you're learning, I'm going to do this every time. So here is the final answer. The final answer is 2 times this, x squared minus 9x plus 14. But x squared minus 9x plus 14 is equal to the product of two linear factors, degree 1 terms, x minus 2 and x minus 7. So what I will see happening a lot is students will forget to write the 2 down. But x minus 2 times x minus 7 is just x squared minus 9x plus 14. And we have to have my factorization equal to the original polynomial. So this factor of 2 right here is not optional. So literally, 2 is prime. This, x minus 2, the GCF is equal to 1. So it's considered a prime polynomial. So polynomials are prime, and they don't have to be trinomials to be prime. And the GCF of x and 7 is also 1. So this is also a prime polynomial. So what we just did, and what we do in every case, when we factor polynomials, the only exception is this number out here at the front need not be prime. The GCF could have been 4, for example. But the polynomials, we're going to factor it into the product of two prime polynomials. So let's look at the next example. So all of these in this particular example are going to have the ability to factor out the GCF. And sometimes I forget to do that myself, but every time you have a leading coefficient on your degree 2 term that is not 1, you should try to factor out the GCF. So I'm hoping you can see here the GCF is 3, because x squared does not occur in every term. So, but 3 divides 6, and 3 divides 9, and 3 divides 3. So this is equal to 3. So 3x squared divided by 3 is x squared. 6x divided by 3 is plus 2x. And minus 9 divided by 3 is minus 3. So now I have, in parentheses, a monic polynomial. So let's see if we can factor it. x squared, constant term, middle term. So think about think about things. This has to be x and that has to be x. So this is negative, so exactly one of the factors is negative, but this is positive. So the smaller of the two factors will be negative. The cool thing about it is this is 3. 3 is prime, so I only have one choice. I have 3 and 1. Since this is positive, the negative has to go on the smaller of the two. So x times 3 is 3x. X times minus 1 is minus x. 3x minus x is equal to 2x. 3 times minus 1 is minus 3. X times x is x squared. My factorization is as follows. So this is equal to 3. And x squared plus 2x minus 3, we discovered is equal to x minus 1 times x plus 3. So we got that one done, and let's do one more. Notice our last one, it's already monic, so let's just see if we can factor it. So this is 2c. X squared term, constant term, and final term. These always have to be x's. So that's positive, everything has to be positive. Well, there is 6 times 4. Do you like that? I like that. 6 times 4 gives me 24, x times x gives me x squared. X times 6 is 6x, and x times 4 is 4x. 6x plus 4x is 10x, so my factorization is x plus 4, x plus 6. So if you got that, then great. Okay, so what I'm going to do now is there's a lot of problems. You need to practice all of these. So what I'm going to do is I'm not going to work them out, but I'm going to give you the answers in case you want to work these. So x squared plus 13x plus 36 is equal to x plus 4. This is for you to check your answers. I'm not, like I said, I'm not working them out. Factorization is really important. So x squared minus 6x minus 27 is equal to nothing. It's prime. No, it's not. Sorry, I'm looking. The next one's prime. I'm just reading off my notes, people. So this is x minus 9, x plus 3. And then this one, x squared minus 3x minus 7 is prime. And there's another list down here. 2x squared plus 20x minus 22 is equal to 2. You factor out the GCF times x plus 11 x minus 1. And then we have 5x squared plus 20x plus 15. So the GCF there is 5, and it factors to x plus 3 times x plus 1. And then the final one you have, I'll show you all of these in just a second, is minus x squared minus 3x cubed minus 10. It really has nothing but a trivial factorization, so you can either say it's prime, or if you want to factor out a minus 1, you can say it's minus x squared plus 3. That's not supposed to be squared. Plus 3x plus 10. So whether you want to call this a trivial factorization, we did factor out a minus 1, and that's our only factorization, and you can call that trivial or not, but clearly even if I factor out a minus 1, what remains is prime. So where did I get all of those? It's the in-class practice problems at the very end of 3.2. So that's it for 13.2. So that's it for 13.2.